This particular problem is regarding distance. So that means we're going to need the equation or the formula that distance is equal to rate times time. So let's see what we're dealing with. We have that Keenan went out on his sailboat on Lake Tahoe one Sunday afternoon. He sailed 5 miles per hour for the trip out. He sailed twice as fast on the trip back. The entire trip took 6 hours. How far did he go out on the sailboat? Okay, so let's do a table with this one. So we know that he took 2 portions of the trip. The first part of the trip, he was going out, and the second part of the trip, he was coming back. And when I make a table with a distance problem, I like to make a column for each of the parts of the distance formula. So I make a column for distance, rate, time, and then the formula itself. So I'm just going to draw a quick little picture of what happened. So we have that Keenan's little sailboat here. He's in the water. And he first goes out a certain distance. That's what we're looking for. We don't know how far did he go. But we know that when he went out, that's his first trip, and he went 5 miles per hour. And then once he got all the way out to where he wanted to be, he came back. That was his second trip. And that time, he was going twice as fast. Well, twice as fast as 5 miles per hour is 10 miles per hour. Now, what do we know about the distance? Well, if we look at our little diagram here, we know that the distance he went out and then the distance he came back are the same. So I can give those the same variable. We don't know what the distance is, but we know that going out and back, he traveled the same distance. How about the rate? What do we know about the rates? Well, it tells us that going out, he was traveling 5 miles per hour, and that coming back, he was traveling twice that, which is 10 miles per hour. What do we know about the time? Let's think about that. Well, we know that altogether, the trip took 6 hours. So that means that the time, let me move this up a little bit. That means that the time going out, so the time for the trip 1, plus the time coming back, the time for trip 2, altogether was 6 hours. So if let's say that I'm just going to call this first time 1. Well, how can I figure out what time 2 is? Because I don't want to have too many variables. I want to have as few variables as possible. So I want to try to figure out a way to write time 2 in terms of time 1. So I'm going to look at this here, where I have that time 1 plus time 2 equals 6, but I only want to I want to know what time 2 is. So in order to get time 2 by itself, I need to get rid of time 1. So I'm going to subtract time 1, but if I do it on one side, I need to do it on both sides. So what happens there is those will cancel out, and I'm left with just time 2, which is exactly what I wanted. And then on this side, I have 6 hours minus, oh, that should have been time 1. So that's 6 hours minus time 1. So now, instead of saying T2 or time 2, I can say that time 2 is just 6 minus time 1. It's the 6 hours total that it took for the whole trip minus the amount of time it took for the first part of the trip. And I know that the equation distance equals rate times time. I don't know my distance. I do know my rate, 5, for this first part of the trip, times the time. I don't know what the time was. So I'm going to say that's time 1. Distance equals rate times time 1. Then I also know that my distance here is the same as distance here, so I'm going to just write D for distance. I do know my rate, so I'm going to say it's 10. But here I have my time 2, the whole time 2, is equal to 6 hours minus the amount of time that it took for the first part of the trip. So that's distance is equal to 10 times the quantity of 6 minus time 1. Now that I've got these two equations, and I know that the distances are the same, I can set them equal to each other. So that means that I have that distance equals 5 times time 1, and I also have that distance is equal to 10 times 6 minus time 1. These two things are equal to each other because they're both just equal to that distance that Keenan traveled. So I have that 5t1 is equal to 10 times 6 minus t1 time 1. So that again, I'm going to simplify. That's 5t1 is equal to 60 minus 10t1. I'm going to get my constants on one side and my variables on the other. So I'm going to get variables onto the left side, and to do that I'm going to add 10t1. If I do it on the right, I have to do it on the left, and I end up with 15t1 is equal to 60. In order to get the time by itself, I need to do the opposite of what is happening with 15. In this case, I'm multiplying, so I need to divide. Divide on both sides. I end up with time 1 is equal to 4. Now the time here was talking about hours, so that's 4 hours. Is that what it's asking us though? Let's go back to the question. The question is asking that if the entire trip took 6 hours, how far did he go out on the sailboat? Well, how far? That's asking a distance, right? So I know that I can pick either one of these equations to find my distance, because both of these are equal to the distance that he went out. I'm going to pick the more simple one. So I'm going to say that the distance is equal to 5t1. But I just said that t1, let's push that. I said that the distance is equal to 5t1, or 5 times the time. But I know that the time was 4 hours. So I can say that my distance was equal to 5 times 4. That means that my distance is equal to 20. And what type of rate are we dealing with for distance? We are dealing with miles. So my distance is 20 miles. I need to state this into a sentence. I need to state this as a sentence. So my final answer will be Keenan went out 20 miles on Lake Tahoe.